In this video, I'd like to talk about finding inverses of rational functions. And before we look at specific problems, let's just remind ourselves what an inverse to any kind of function is. And in the simplest sense, inverses essentially reverse functions. So let's say you have some function f and it has an input space or a domain, let's say of values 1, 2, and 3, and its output space or its range, let's say, is 5, 7, and 9. So a function will take an input and will map it to some type of output. Let me use a different color for that. So it will take this value of 1 and give you an output of 5. So if we plug 1 into our function f, we would get 5. And same for 2, that would map to 7, and 3 would map to 9. Now, the inverse function essentially does the reverse of that. And we denote that with f inverse. So this is not f to the minus 1 power, this is just the inverse function notation. So with the inverse function, if we plug in the output from the original function, it will tell us what the original input was. So if you plug 5 into the inverse function, it would map to the value of 1. So the inverse function essentially goes the other direction. And we can formally define it to say that the function evaluated at some letter a or number a gives you the value b, and the inverse to this, f inverse, if we plug in b to our inverse function, it would give us the value of a. So in some sense, inverse functions reverse each other. And in another sense, especially when you're dealing with the variables x and y, they switch the variables. So inverse functions, we could say switch, let me rewrite that, switch x and y. And that's effectively what we're going to do here. So we're going to rewrite our function. So we have that g of x is 2x minus 1 over x plus 3. And our first step is that we're going to set this equal to y, since y and our function value on the xy plane are the same thing. And once we set this equal to y, we're just going to switch. Anywhere we see an x, we'll replace it with y, and anywhere we see a y, we'll replace it with x. So we can say at this point, we will invert it. We will take the inverse of this function, and we have that 2y minus 1 over y plus 3 is equal to x. And at this point, we just need to solve for y. And whatever we get for that y value, that will be our inverse function. So let's go through that algebra. And let me just make a little bit of room so that we can work this out. So let's bring this up here. And our first step, notice we have y in the denominator. We have this rational equation that we want to solve for y. So to get y out of the denominator, we are going to multiply each side by that denominator. And we'll just assume that y cannot be negative 3 here. And by multiplying both sides by the denominator, on the left-hand side, they will essentially cancel each other out. And we can rewrite this as 2y minus 1 is equal to x times y plus 3. So at this point, since we want to solve for y, and it's on both sides and within parentheses, we will first distribute the x and then collect all the y terms on one side of the equation. So 2y minus 1 is x times y plus 3x. Now let's move everything to the left, all the y terms. So we'll subtract xy on each side. So we have 2y minus xy. And then everything that doesn't have y in it, we want to move to the other side. So let's add 1 to each side as well. So then we're left with 3x plus 1. So we just subtracted xy on each side and we added 1 to each side. Now that we have y on the same side of the equation, we'll factor it out since we can't actually combine these terms yet since we don't know what x is. So we'll factor y out. So we have y times 2 minus x is 3x plus 1. And lastly, since we have a product here, y multiplied by something, we will cancel that out with division. So let's divide each side by this 2 minus x, and we'll end up with y is 3x plus 1 divided by 2 minus x. So this should be our inverse function. Let me just say this is also equal to f inverse of x. And so we'll box all of this. And actually, I should mention this is not f, this is g. So let me correct that very quickly. So y, in this case, since our function is g of x, y is equal to g inverse of x in this new equation we found.